So Spearman's rank correlation coefficient. So he was a British psychologist, and he developed this method where we will be assigning ranks to the correlation coefficients, correlation values that are given to us, and then we will find correlation coefficient for the two set of variables. Now the formula that has been proposed by Spearman's correlation coefficient is capital R is equal to 1 minus 6 sigma d square divided by n cube minus n. So the important value to be calculated from the problems are d square, and if you add the d square values, it is called as sigma d square, and then you multiply it with 6 and divide it by n. So what is capital R? Rank correlation coefficient. D is the difference between the ranks. Since we will be ranking the data that is given to us, if we find the difference between the ranks, that will become the value of D. And then we have number of pairs of the items, that is nothing but how much number of data is provided to us, that will be the n values. And the correlation coefficient capital R will range between +1 and -1. And this Spearman's rank correlation coefficient is usually calculated for the qualitative characteristics. Okay, these are such characteristics where we will not be considering the numbers. These are qualitative in nature, like intelligence, beauty, the way the person sings or dance. Okay, such things which cannot be quantified, those are called as qualitative. Now there are three types or there are three situations where we will be solving this rank correlation. First one is when the ranks are not given. They don't give us ranks, so we have to directly assign the ranks and then solve the problem. Okay, the second scenario is when ranks are given. So in the second scenario, they will only give the ranks in the question, and we just have to find the correlation coefficient. In the third scenario, the ranks may be tied up. So 2 or 3 of them can have same ranks here, and how are we supposed to solve those repeated ranks? So in that, we started with first type, that is calculation of R when the ranks are not given. Now in that, we solved the first problem. So we have got the data of X as well as Y. They have given the data here. Okay, X is a independent variable, Y is a dependent variable. Coming to the tabular calculations, computation of correlation coefficient, or you can write the heading as computation of Spearman's correlation coefficient. Okay, so that also can be written here. Now coming to the calculation, X and Y is considered from the question, and we have to assign the rank. Now how do we assign the rank? Either the ranks will be assigned in ascending or descending order. So here we are following the descending order for the ranks. So the highest number will be ranked as 1, and then the next lowest will have the rest of the ranks. Now if you see the data of X, the highest rank or the highest number is 98, so it gets the first rank. Then the next number is 95, second rank. Then the next number is 81, so third rank. Then the next number is 75, so 4. Then it is 61. Then it is 59. After 59, we have 55 and then 53. So this is how you assign the rank. Simply find the highest number. From there, find the lowest, the next lowest, and keep giving the ranks. This is the same system like how we use in the schools and colleges. The highest mark scored by the student will get the first rank. So all the ranks that you have got here is the R1. See, all the same ranks are being given here. For your understanding, I've just marked it here, but seeing these values, assign the ranks in a separate column. Then similarly for y2. Now which is the highest number? 47 is the highest number, so first rank. Then we have 45, so that will be second rank. Then 40 is third rank. Then 39 is fourth rank. Then we have 37, then 32, 30, 25. Okay, so 8 ranks we have. So we have the number of data that we have is 8, and totally 8 ranks are given to the data. Now after this, the next step is to find the difference between the ranks. Now what is this difference between the ranks? We have already calculated, or we have already seen what all ranks that we have assigned. Now the next step is just to subtract these two columns. So go by R1 minus R2. Don't take the other way around. Okay. Both of them have 1, 2, 3, 4 values. Just subtract R1 minus R2. So here D is equal to, this difference is called as capital D. Okay. So D is equal to R1 minus R2. You'll get certain minus values and few plus values also. So be careful with that. Retain the minus values as it is. Do not change anything. So 6 minus 1 is 5, 8 minus 5 is 3, 1 minus 8 is minus 7, 3 minus 4 is minus 1, and then 4 minus 7 is minus 3, 5 minus 6 is minus 1. And here 2 minus 2 is 0, 7 minus 3 is 4. Okay, so once you find out the D values, next find the D square. Okay, square the values and you get the D square. Now the important total that is required to solve the Spearman's rank correlation coefficient is summation of D square. Okay, when you add all these numbers, you get D square, and that total is very important. Along with that, the value of n, that is n is equal to 8. That is important. So we have both the values. Now let us go and solve it. Now in examination, you need not write this explanation for each of the problem. This is only given here for the first problem for you to understand. That's all. Okay. You can directly finish your table calculations and then apply the formula. So what is the formula? R is equal to 1 minus 6 sigma D square whole divided by n cube minus n. So 1 minus 6 into 110 is the total value. Okay, 110 is the sigma D square divided by n is 8. So n cube minus 8. Okay, this is 8. This is not 6. This is 8. Okay, then 6 into 110 is 660 divided by 8 cube is 512 minus 8. So 661 minus 660 divided by 504. So 660 divided by 504 will give you the value of 1.3095. Now when you subtract this, the value of R is going to be minus. Why it is minus? 1 minus 1.3. 1.3 is more, right? So that is why you get the minus value. Okay, so this is how we calculate the value of Spearman's rank correlation coefficient. Okay, once we get this value, we have to do the analysis. We have to interpret the value of R. Now interpreting the value of R remains same like how we did for Carl Pearson's. Okay, we used to draw the timeline, plus 1 and minus 1 here, and we have 0, and then we have two other points. One is plus 0.25 and the other one is 0.75. On the other side, minus 0.25 and minus 0.75. Okay, now this number is a negative number, so which means it is negative correlation. Okay, since the number is negative, it is negative correlation. And let us see where we can place this number. 0.3095. So 0.3095 is placed in between 0.25 and 0.75. So it is on a moderate degree of correlation. Correct? Moderate degree of correlation. So it is moderate degree negative correlation between the variables. Okay, so this is your first question when the ranks are not given. Okay, any doubts until here? Did you all understand? Good. Now let us go to the next question. Now this question also is when the ranks are not given. Okay, so here you are supposed to calculate the rank correlation from the following data. Now in this following data, they have given us the marks in statistics and the marks in mathematics. And they've clearly, see, they will clearly state you are supposed to calculate the rank correlation. So when they are talking about rank correlation, it means that they're asking you to calculate Spearman's rank correlation. That is what they are trying to say to you. Fine. So here rank correlation is given. Again, we are going to consider the marks in statistics as X and the marks in mathematics as Y. Okay. And copy down the questions. Sorry, copy down the numbers from the question. Now, since the ranks are not given to us, let us assign the rank. Now, in this data, in the data of X, which is the highest value that you can see? Which is the highest value you can see? $72. Okay. So 72 is the first rank. Which is the next highest? After 72, which is the next highest? 62. Okay. Next highest? 60. After that, fourth position, 56 I can give. Then after 56, anything else in 50? Okay, I have 52. So this will be fifth. After 52, something in 40s, 6, then 7, then 8, and then 9. So here we have 9 data. So n is equal to 9 and we have 9 ranks which we will put here. Similarly for Y, highest number is 78 is highest number. So 1. After 78, I have 70. This is going to be 2. After 70, something in 60s. 65 is 3. 62 is 4. 60 is 5. 54 is 6. 38 is 7th rank. 32 is 8th rank. And 31 is 9th rank. Okay. Now we have got the ranks. We have written the ranks in a separate column here. Now find the difference between the ranks. Just subtract these two columns, that is R1 and R2. So once you subtract, you get D is equal to R1 minus R2. Now once you get R1 minus R2, the next thing what you will have to do is, what you are supposed to do is that you have to square the values of D square. Okay, so once you square the values here, so you will be able to get the total, you will be able to get the total of sigma D square. So sigma d square is equal to 40. This is the total that we have got. Now once you get the sigma d square value and you also know what is the value of n, okay, what is the value of n, so you can apply that in the formula to find the r value. So 1 minus sigma d square by n cube minus n. So 6 into sigma d square is 6 into 40 divided by n cube minus n. 1 minus 6 into 40 is 240. 9 cube is 729 minus 9. So 1 minus 240 by 720. So the value of correlation coefficient that you get is R is equal to 0.06667. Now, since it is a positive number, I can say that it is a positive correlation. Okay, the analysis is done on the same timeline. So plus 1 and minus 1, and then you have 0, 0.25 and 0.75. And this value of 0.06 comes in between 0.25 and 0.75. So we can say there is a moderate degree of positive correlation between the variables. Okay, so this is when the ranks are not given. So you have to be careful in analyzing the question, first of all, to understand if the ranks are given or if the ranks are not given. Okay, understood? Any doubts in this question? Everybody understood? Okay, so that was your first type of problems. Now the next type of problem is when the ranks are given. Now in this type of problem, you will not have the X and Y data, but they will give you the ranks. Instead of giving, see, let us compare this question and the previous question. Now, instead of giving you the X and Y data, like how they have given here, they have directly given this column and this column. Okay, so the effort that you put in finding out the ranks is saved. You need not find the ranks. Okay, so what you are supposed to do is just find the difference between the rank and square them. So once you find the difference between the rank and if you square them, and then use the same formula to find the resultant. Okay, let us see the question here. Firstly, what is the situation? Calculation of R when ranks are given. When ranks are provided to you, what you're supposed to do? The ranks given by 2 judges in a music competition of 8 singers are given below. Find the rank correlation coefficient. So here the judges are given ranks for music competition. And what are the ranks? See, the first participant has got first rank for from the judge 2, but he has got second rank from the judge 1. Okay, so that is the value. Then for the second participant, judge 1 has given first rank and judge 2 has given third rank. These are the ranks that has been given by the judges. It's just the judgment of the ranks, and we are supposed to find the correlation coefficient for this. Okay, now why are we doing this? I mean, you might get a lot of questions saying, what is the use of doing all this? Okay, the major use of doing all this is in the research methodology. If a person is doing a research on, let's say, out of all the music artists that is available in India, who all can, sustain in this lockdown period. Now lockdown periods during pandemic has taken away a lot of musical concerts. Okay, if you happen to know, they used to have musical concerts in summers, and then we had these festival times, Ganesha festival, and then Ganesha Gauri festival. We had Navaratri, Dhandiya, which was actually happening, and now Deepavali is approaching. So in all these times, the music concerts would have gone down. How has it affected the lives? That is one of the example I'm giving. Now like this, they would have done lot of research throughout. They can do the research on how many students drop out in the 10th standard, how many of them go to uh, pre university or PUC, or how many of them actually completes the degree course completely. Many of them will join for degree, but then they end up discontinuing in between, right? So all these research methodologies, for all this research or survey, we can use the correlation coefficient, where we will be able to arrive at some resultant saying, okay, 70% of people completes the degree, so 30% of people will get dropped out on a overall basis. Okay, so that is the usage of this correlation coefficients in the research. This is very basic concept. Based on this correlation and regression, there are many concepts which has been created. Fine. So this is the basic concept you will have to learn, and these concepts are useful in a long way throughout your degree, final year, and then even in your master degree, you will be using this correlation and regression. Now, let us see. Now, Judge 1 has given the ranks, Judge 2 has given the ranks. Okay. Now, just see if anybody has got the same rank. See, 1, 2, 3, 4, 5, 6, 7, 8. Okay. There are no repetition of ranks, right? So the one is not repeated anywhere here. One repeated here is okay. But in the same column, the number should not be repeated. Fine. So here also 1, 2, 3, 4, 5, 6, 7, 8. No numbers are repeated. So now let us find the difference between R1 and R2. I told you, don't get confused and do R2 minus R1. No, it is R1 minus R2. Even if you get minus values, no problem, go with that. Okay, so 2 minus 1 is 1, 1 minus 3 is minus 2, 4 minus 2 is 2, and so on. You find the difference for R1 and R2, and that difference is called as D, capital D. Correct? Now after this, in the next step, what are we supposed to find? D square. Just square all these values. 1 square is square, minus 2 square is minus 2 into minus 2. You will get plus value. Minus 5 square, again minus 5 into minus 5. Minus into minus is plus. So again you will get plus 25. Okay, like this you'll find the value of D square everywhere. And then when you total, you'll get sigma D square, which is equal to 58. When you add all the values of D square here, you get 58. Okay, now once we know the value of sigma D square, let us check the value of n. 1, so 1, 2, 3, 4, 5, 6, 7, 8. So the value of n is, the value of n is equal to 8. We have 8 data that is given to us here. So 1 minus 6 sigma d square by n cube minus n. So 1 minus 6 into 58 divided by 8 cube. Sorry, this is not square, this is cube. Okay, 8 cube minus 8. 8 cube minus 8 is equal to 1 minus 6 into 58 is 348. 8 cube is 512 minus 8. So you get 1 minus 348 divided by 504. And the resultant value is going to be R is equal to 0.30953. Okay, so this is what we get at the end. Now, based on the timeline here, I can say this as positive correlation, negative correlation. The value is between 0.25 and 0.75. So what is the conclusion I can give here? Who can say me the conclusion? What is the conclusion I can give? Moderate. After that, after moderate, say me the full conclusion. Okay. Others? I want few more answers. Which correlation is it? Positive, negative? Positive? Okay. And then which degree of correlation is it? Low, medium or high? Okay. Low, medium or high? Which degree of which degree should I consider? Moderate degree, positive correlation. Everybody is clear with that? So there exists a moderate degree positive correlation. This is what you're supposed to write for the problem here. Clear? Everybody understood this problem? Any doubts? Can we go to the next problem? Okay. Now, moving on to the next problem is we have more data given to us in this problem. 10 competitors in a fashion show are ranked by 3 judges. So there is a fashion show which is happening and there are 10 people who are participating. Out of that 10 people, they are giving the marks for them. Okay, so there are 3 judges, judge 1, judge 2 and judge 3. Now in a fashion show, it is a, what do you say, it's more of a qualitative nature. You cannot say so they have bought this expensive dress or they've bought this thing, or I cannot count them saying how many pairs of or how many pieces of dress are they wearing. That is not the way they judge a fashion show. Okay, the fashion show is more of a qualitative nature. There is a feel which, or there is a vibe which comes out of each participants. There is an attitude which is being shown on the fashion ramp, where the judges with the experience of judging the fashion shows would come down and judge it. Correct? So that is why we are using rank correlation. So in the examinations, when you get a questions which is talking about the fashion show or singing competition or dancing competition, okay, all these things are more qualitative in nature and you should immediately analyze that it is rank correlation. Okay, so 10 competitors in a fashion show are ranked by 3 judges X, Y and Z in the following order. Okay, so here they have given us the ranking of the 10 participants, but by each of the judge. So judge 1, let us consider judge 1 to be X and judge 2 to be Y and the judge 3 is Z. But if you remember, we usually consider 2 data at a time. Okay, we have not solved 3 data until now. Okay, now let us read the question and understand what they are actually asking us to do. So if you see the question here, use rank correlation, clearly mentions rank correlation to find out which pair of judges, pair means two of them. Either it can be XY or it can be YZ or it can be XZ. Okay, which pair of judges has the nearest approach to fashion design? So based on the ranking that they have given, see, everybody will have their own way of seeing the fashion show. Few may like it, few may not like it. Okay, it depends on a person perspective or person's approach. So here they're asking us which pair of judges has nearest approach to the fashion design. Let us go to the problem and analyze it. Okay, so firstly we have to write down all the 3 ranks that is given to us. These are the ranks that is directly given to us and it is not the XYZ data. Okay, this is not the XYZ data. These are the ranks that is given to us for the XYZ data. Fine. So R1, R2 and R3 are the ranks given by Judge X, Judge Y and Judge Z. Okay. So firstly, we will consider the Judge X and Y. Okay. First, we will consider who? Judge X and Y. So in that case, R1 minus R2 is supposed to be found out. Just subtract R1 and R2 column to get D1. Here be careful, don't just write D, write it as D1 because we'll have to find the result for 3 pairs of judge. How 3 pairs? XY, YZ and XZ. Okay, 3 pairs of judges we'll have to find. So here in this we will be first finding out the difference between R1 and R2. And if you see the difference, 1 minus 3, 6 minus 5, 5 minus 8, 10 minus 4, 3 minus 7, 2 minus 10 and so on, you will calculate the difference. So once you calculate the difference, that will be D1. And what is the next important step? Is to square that D1. So D1 square. If you square all these values, you will get D1 square. Add all the square values. The important value for the calculation, is sigma D square, that is nothing but 200. So for the first pair of judge, we have got the important value, that is nothing but 200. Okay, so that will be your first D1 calculation. Did you all understand the D1 calculation? Okay, now for the next calculation, that is D2, I am going to consider R2 and R3. So first we considered X and Y. Now we will consider Y and Z. Okay, so R2 and R3. So I will find out R2 minus R3. So subtract these two. 3 minus 6, 5 minus 4, 8 minus 9, 4 minus 8, 7 minus 1, 10 minus 2, 2 minus 3, 1 minus 10, 6 minus 5 and 9 minus 7. So if you do this, you will get few positive values and few negative values. Okay. Now once you find the differences between two of the ranks, then square the ranks. Same procedure. So D2 square, if you square all of these values, you and add them, you get sigma D square for the next two ranks or the next pair, that is Y and Z, to be 214. Okay, so this is the second pair. Now, final pair that we are supposed to consider is X and Z, right? X and Z is the final pair which we will consider. So that is nothing but R1 and R3. R1 and R3 will be considered. So R1 and R3, when you consider, you also have to consider the values of X and Z. Okay, so if you consider the value of X and Z, now what will be the subtraction? R3 minus R1. Okay, it is Z minus X. So R3 minus R1, you will have, oh, okay, wait, it's not R3 minus R1, it's R1 minus R3 only. See, 1 minus 6 is minus 5. Okay, this is R1 minus R3. Fine. So you will get the values of D cube, D3. Now once you get the values of D3, you will have to square them, that is D3 square. And then when you add all the values of square, you get the final sigma D square, that is nothing but 60. So we have got sigma D square for XY, YZ and XZ. Okay, so this is the table calculation for this particular question when the ranks are given. Any doubts until here? Any doubts in the table calculation? No doubts? Everybody understood? Okay. Now we will consider all that sigma D square numbers and we will find the value of R here, that is rank correlation. So the formula remains same for all of them, but just that we should be careful with the numbers. So firstly R1, 2. So judge 1 and 2, and then judge 2 and 3, and then judge 3 and judge 1. Okay, so these are the values that we get. Now, once you calculate using the formula, the resultants will be these values. Okay,